Hello and welcome to BRB Time, where today we are going to be trying something a little bit different. Today I'm going to be going over just what the flux sunspots are, why it matters, and what they can do to us. So, before we begin, let's go ahead and explain what the sun is. According to NASA, the sun is a star, a ball of hot, glowing gases. The sun's influence extends beyond even the orbits of distant Neptune and Pluto. And without the sun's heat and energy, there would be no life on Earth. Also, according to NASA, every 11 years, the sun's magnetic field goes through what's called a solar cycle. This is the process through which the sun's magnetic field gets completely flipped, causing its north and south pole to reverse. It then takes another 11 years to flip back. This affects activity on the surface of the sun, such as sunspots, which are caused by the sun's magnetic fields. As the magnetic fields change, so does the amount of activity on the sun's surface. So by now I imagine you're questioning, what in the flux actually are sunspots? I can tell you that. According to space.com, sunspots are darker, cooler areas on the surface of the sun in a region called the photosphere. They are caused by interactions with the sun's magnetic field, which are not fully understood. But a sunspot is somewhat like the cap on a soda bottle. Shake it up, and you can generate a big eruption. Sunspots occur over regions of intense magnetic activity. And when that energy is released, solar flares and big storms called coronal mass ejections erupt from the sunspot. According to Dr. Rosa Williams, a professor of astronomy and the head of the West Rock Observatory, sunspots appear dark against a bright backdrop of the photosphere because they are cooler. In this case, cooler means about 4,500 Kelvin instead of about 6,000. This happens because magnetic fields trap cooler plasma at the solar photosphere, preventing it from sinking deeper into the sun. Usually, cooler plasma sinks and hotter plasma rises in the convection cycle. But magnetic fields trap the cooler plasma at the photosphere, interrupting this cycle. The laws of thermal radiation say that hotter regions give off more photons per unit area, so they appear brighter. Thus, compared to other areas on the sun, sunspots, being cooler, appear darker. Sunspots usually appear at both ends of a magnetic loop that pushes its way out of the photosphere. Each end traps cooler plasma where the magnetic field lines come out of and go back into the photosphere. So the dense magnetic fields that create sunspots have opposite magnetic polarities, one at each end of the loop. And this is where Flux gets involved. She goes on to say that the magnetic field loops that cause sunspots also cause other solar phenomena. Some of the solar plasma gets channeled by these magnetic field loops, so the gas flows along the magnetic field lines. This makes visible bright loops at the edge of the sun, called prominences. If the magnetic field lines get too close together, they start to reorganize, disconnecting and reconnecting. These would be regions of high magnetic flux. This can release a burst of plasma and radiation called a solar flare. Sometimes a magnetic bubble forms, which rises above the photosphere. This bubble traps material from the hot, thin outermost layer of the sun, the corona, and carries it out into space as a coronal mass ejection, or CME. To put this in mathematical terms, because flux refers to the density of a magnetic field that is normal to the surface of a given object, magnetic flux is a product of the average magnetic field times the perpendicular area that it penetrates. So what's your point, you may be asking? What does this have to do with me? What does this have to do with Earth? Well, in the emails that I shared with Dr. Rosa Williams, she went on to say that when sunspot regions erupt as a flare and/or coronal mass ejection, they send billions of tons of plasma and radiation into the solar system. If that plasma is erupting towards Earth, it will interact with Earth's magnetic field. Our magnetic field protects us from most of the plasma effects, but sometimes that plasma may interact with Earth's magnetic field and cause a geomagnetic storm. And a geomagnetic storm would have all types of effects for us here on Earth. Just for an example, ions in the plasma could damage satellite equipment. Ions could cause air molecules to glow, causing the northern and southern lights. The radiation levels would be really high for astronauts out in space. And the ions would disrupt the ionization layer of our atmosphere. And since we use this layer to communicate through radio waves, long-wave communications could be disrupted. I chose this topic because I have a love for astronomy and physics, and I'm always looking for a way to combine them. I feel that I have learned a great deal of information from this project, and from this semester. If this video has helped anyone, please feel free to let me know, or correct my mistakes in the comments below. I want to leave a big thank you to all of the people involved in the video, and to the viewers for watching. So, until next time, so long, Sunspot.